Find the critical numbers of r of q equals q plus 2 to the fourth power by q squared minus 8 to the second power. Now, while it might not look like it, this is a polynomial function. It's just already in a somewhat factored form. So we know this is a polynomial, and so its domain is again all reals. Alright, so let's calculate the derivative. Here we'll have to use product rule, and we'll also have to use a chain rule. So let's see, then r prime of q, differentiating the first factor, I would have 4 times q plus 2 to the third power times the derivative of q plus 2, which is 1. Alright, so I'd have that. And then I'd leave the second factor alone, times q squared minus 8 to the second. Plus, now I'll leave the first factor alone, q plus 2 to the fourth power, and multiply by the derivative of the second factor. So I'd have 2 times q squared minus 8 to the first power, and then from the chain rule, times a 2q. Alright, so there's the derivative, but this is kind of ugly to work with. Let's do some factoring. I noticed that in each of the two terms, and so again, let's be careful, let's understand. This is a term, right? This is my first term, and here's the second term, right? Those are the pieces of the expression separated by the addition sign. So let's look over that and say, are there any common factors that we can pull out? All right, let's see what we have here. We have a 4 over. We have a 4, and I have a 2 times a 2. I can factor out a 4. I see that there's a factor of q plus 2. All right, I have q plus 2 to the third power, and I have q plus 2 to the fourth power. We generally want to factor out the lesser exponent in these situations. So I'm going to factor out q plus 2 to the third power. Similarly, I see a factor of q squared minus 8. I see a factor of q squared minus 8. And choosing between the second power and the first power, I'm going to factor out a q squared minus 8 to the first power. And I'm going to write the first power on purpose here. Okay, then what's left over? From the first term, I factored out the 4, I factored out the q plus 2 cubed, and I factored out a q squared minus 8 to the first power, so I'd still have a factor of q squared minus 8. Plus, alright, from the second factor, I again factored out the 4, I factored out a q plus 2 cubed, and I originally had a q plus 2 to the fourth, so I have a q plus 2. I factored out the q squared minus 8 to the first power, and I still have a factor of q. Alright, so r prime of q then is 4 by q plus 2 cubed by q squared minus 8 by q squared minus 8 plus q squared plus 2q. So that's 4 by q plus 2 cubed by q squared minus 8 by 2q squared plus 2q minus 8. Now, again, I could do some more factoring here. Notice that there's a common factor of 2 in that trinomial. So let's factor out that 2. So then I have 4 times 2, right? I have 4 times 2. So then that's 8 q plus 2 cubed, q squared minus 8, q squared plus q minus 4. So there's a factored form of r prime of q, but now we're still trying to find the critical numbers. So now setting the factors to 0. If q plus 2 cubed is 0, that would imply that q equals negative 2. if q squared minus 8 is 0. That would imply that q squared equals 8, so then q is, not g, q is the positive or negative square root of 8, or if you simplify that using what we know for radicals for square roots, q is plus or minus 2 times the square root of 2. And then finally we'd have the q squared plus q minus 4 equals 0. That will not factor. You can try it if you want. So I'll apply the quadratic formula. So then q would equal negative 1 plus or minus the square root of 1 plus 16. So that's a 17 over 2. So there are the critical numbers. All right, the critical numbers of R of q are negative 2 plus or minus 2 root 2 and negative 1 plus or minus the square root of 17 over 2.